Okay, my friends, I am claiming that Rod Warren and I have created controlled fission and fusion, and there it is right there, using lasers and venturis. And I will explain to you. So this is subatomic. This is light. This is not an atomic realm. This is light, and we actually made a subatomic nuclear explosion. And the energy should be off the charts. I am going to explain to you. I don't see why we can't get some free energy out of this. You make your determination. But my claim is, and I will stand up to any physicist in the world, my claim is that we created subatomic fission and fusion. Now this is atomcentral.com, and this is going to be a test house that they set up, and I'll explain to you as we go through. I'll stop it here and there. All right, the first thing that goes off is brilliant white. Okay, that's all you see. That's it. Now what happens? The house didn't move. It's still not moving. It's just burning up. What we're seeing now is just the poles are just filling, just smoking. The wires, just smoking. This roof, the facade, everything is just smoking. It hasn't moved. It hasn't moved an inch. It's just smoking. Well, why is that? I mean, this is extremely slow motion, so you wouldn't detect this if you were just looking at it. But in a slow motion, we can understand what's going on. And it's just continuing. Look, more and more smoke, more and more smoke, 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 smoke. No movement. No push. So what does that tell you? It says whatever is doing this has no mass. Mass is weight, is something that can push something else. There's no mass here, but there's a hell of a lot of energy. This thing just started smoking instantaneously. This would be smoking so fast, you wouldn't be able to tell. And here it comes. The black will come after all the smoke. It's been all absorbed by that. Boom, there goes the heavy duty stuff, and that's the black coming out of the center, which follows the white particles, which are the glowy particles. And the reason it is, they make one of these things so dense, and they can't see the black inside. They never have, nobody's ever seen it, because it's inside. It will always, always, always be inside. The only time you can ever see that black is if it obstructs white coming at you. That's the only time, and we have shown that. They just don't know what they saw. It's Fermilab or CERN. They just have no clue. The black right there is the black that I'm telling you, you can't see. It's dark matter. It's dark. You cannot see it. The only way you can see it, if it gets on top of something that glows behind it. So if there's something white coming from behind and you put that black dot of mass on top of it, you won't see it. That's what happened here. And that's why they say there's always a glowy ridge around the black ones. You have to, because otherwise you won't see it. And this one can get big, it can get small. And we see that too, because here's the bigger one, it gets charged up, and there's the discharging one. And here is the dark matter that attracts to it. And the only reason you see it is because the glowy stuff is behind there, and you can't see it because the black is on top of it. All right, and the same thing here. When they hit the venturi, they divided. The black and the white did fission. That's fission right there. And when they come back together, it's fusion. And this is accelerated light, which none of this stuff is supposed to be able to happen. And you can see it's obviously happening. We're accelerating the light. It started out much slower than that. All right, here's what happens. Here's the wave-particle duality. And the wave is because you have a surrounding, you see this here? You see that? I'm pushing that other magnet. That's because I have a surrounding field and the particle is in the center. The particle's in there somewhere. You don't see it, it's just too small. But the field is coming out. And the field pushes every other field, which every other particle has a field. Now, at this point, it starts to accelerate. and we start to get the photons visible. All right, and this is coming out of this is like if we were looking in this way. We can see all the Higgs fields, and that's something they're real hyped up about, is the Higgs fields. These particles here are the black and white particles. There they are right there, black and white. And the only reason you can see the black is because there's white behind there coming this way. Otherwise you wouldn't see the black. It just wouldn't be there. It's just not there. There's black everywhere. There's black everywhere in here, but there's just no white behind it to highlight it. Okay, I got called away a couple of times, but I did show that the white particles just make the thing glow, and then the black particles smash the house over. Now, the question was, when the laser shoots out, it's shooting out black and white particles. Does the laser battery get less weight? And I say no, because those white particles did not take black particles and go with them. They stimulated a crystal, and the white particles went back to the black that never left. The black never left, so you're not going to lose weight on a battery because the black never leaves.
I see what you're...
Okay, my friends, it's come down to Albert versus Roger. I've been saying for a long time that physics is really absolutely broken because of the speed of light law. I mean, it's insane, it's crazy. And the vacuum of space is just not a vacuum. They know this. Not only that, light does slow down. There is no question about that. And if it's not in a perfect vacuum, it might not slow down. But there is no such thing. So this is Roger versus Albert. Einstein says E equals mc squared. It's wrong because light changes speed. It goes up or down. I say that energy equals mass times push, more or less. You have a certain mass that things have. They weigh a certain amount. On gravity, because of this particular gravity, they weigh a pound. If this gravity was twice as much, they would weigh 2 pounds. Simple as that. It's the gravity is the pull, and the pull is dark matter. The Earth we're standing on right this minute is basically dark matter, surrounded by electrons that want to get in. They want to get in and warm things up. Electrons warm things up, they burn things. The black particles are dark matter, and they're just mass. So I say that mass times the push, if you threw it, obviously it's going to have some energy. If it's just sitting there, there's zero energy. So let's get into this. Okay, my friends, I've got a bunch of pictures here to show you about the difference between red and green and blue and the push and the mass factor. Now, I'm going to come up close and we're going to look at them, and then I'm going to leave it at that, because dipole electron flood theory has to be examined. It absolutely is required to show what I have shown, which is the same particles that Fermilab has found. Fermilab point particles. Here they are right here. These are the smallest particles that they can find to exist. I have found them exactly identical, and they do exactly identical what they said. The black is always surrounded by a glowy field and behind it, because it's dark matter, it won't let light pass through it. It's not emitting any light, it's not reflecting any light, it's blocking light. These can get bigger and smaller, which is the particles that are energy, and they have no weight. And I've shown this with the atomic bomb blast, and all that stuff has been supported by physical, material, experimental evidence. Now, I would like to speak to somebody in the really top-end physics realm about light, and I've been trying to contact, and I just get no responses, because I'm just not part of, I'm leaving the standard model, because the standard model is not right. They know it's not right. It's just not a question of is it not right. It's just a question of how wrong is it. Well, it's in the middle of being totally wrong. It's not totally wrong, but it's got some changes, a lot of changes, and it affects everything right up the line, the whole shooting match, all the way this way down to biology and chemistry and enzymes that are in your body, how fast they work and how much chemistry those little enzymes can do. In 1 second, they can do millions and millions of years of half-life breakdowns in microseconds. Without them, we die and fall over dead. That's really got to be examined. Is all of these different energies. I mean, there's so much that's just not been understood because of this. Light never slows down. They're talking about Webb telescope finding things that are so far in space that, and they're talking like it's a fact. It's just silly. Here's what space looks like. You think light doesn't slow down coming through there? You think the speed of light coming through there is the same as light coming through there or coming through there? We know particles slow down and they speed up. There's no question about that. Experimentally, I'll show you this right now. Okay, so this is my proof, my evidence. Light can slow down and speed up. We sped it up right here through a venturi. That is light speeding up and then exploding here. That is fission. And the black came back to the white, that's fusion, which adds another dimension to this. Where did the black come from that's adding over here? Was it just laying there, or did it jump from here over to there? I don't think it jumped over. So is there just extra blacks laying around, black particles that creates a little bit of a confusion for me. I got to be perfectly honest with you. No, I'm sorry. This is from Fermilab. They put this out. This is backwards. This is where the matter is. This is where the energy is. But they find these together. And this is one of the smallest particles. This is from the same articles that showed, well, hold on a second. All right, this is the article I'm going to show you. This is actually copied right from their article. And it's like I said, exact same deal that we have, and these are the particles. This is from 2013, and they work exactly like Don Lincoln said in this article. This one has all the mass, never changes size. This one can get big and small. This one, like he's showing, you can magnify it and see it and get bigger and bigger as you magnify it, but that's all. This one just gets bigger and bigger by itself when it goes flying through mass. And that's one of the articles. Those are those point particles that we found in our experiments too. And he also says empty space isn't empty. It's like this bubbling root beer. It's just everywhere. And he's right. I showed those particles I show here. From my good friend Mason, absolutely phenomenal research that I've been doing with people that are excluded from doing research unless they want to go in for the money and all that business, the big funding things. Then their research will be allowed to be seen. If not, no, don't look at it, because that'll take away from the funding. That's the way I'm seeing things now. That's just my point of view. That's my opinion. But I'm going to tell you right now, if you think light's coming through here at the same speed and nothing affects it, you're wrong. Light is very easily affected by, it can slow down and it can speed up. It has, Einstein totally wrong about that. And he's totally wrong about light having no mass. Light has mass. Everything there is made of light. I call it atomic vapor. You hear me? Atomic vapor. I've had that statement since 1970. All it is the particles together stream through, and they're vapor. And at a certain point, when you get in gravity and so forth, and they get pulled together, then they start to turn into matter. And then they get mass. And then and they build and build and build and build and build. The more light hits, the bigger the thing's going to get. The Earth is absorbing energy all the time. It's not just energy. It's absorbing the black particles too. It's growing. The Earth has been literally growing. Not hugely amount, but whatever light hits it is absorbed. It's absorbed into the ground. All right, so we know they're particles. This is from Fermilab. We got the same thing. So we know they're particles. What else do we know about light? We know we can accelerate it, because this started out just like a sort of a round wave. And that's what happens when you take magnetic fields, which this is just another, it's a magnetic particle in there. It has a field surrounding it. And if you take those, like these right here, look down here. These are two particles. You see that? So we know we're pushing against something that's going to excite that field. Anytime you get a push to shove and you get excitation, all right, this is dramatic. That is off the charts excitation. Way beyond anything that, it's 100% white particles. The black has been excluded, and I'll show you where they are. And they come back to form here. Now, I know they don't jump over it. In my mind, I can't see that even being a possibility. But these white particles do find black particles over here to turn back into Higgs fields. Whether the black ones are just laying around waiting to be attached to something, I don't know. At this point, I don't know. There may be more black particles than there is white, and they're just sort of laying around extra ones. I really don't know, because they do find partners over here. Let me show you what this looks like close. Well, first of all, let me just do this. I think I already did this. Let's do it again. The field is here, just starting to accelerate, pushing everybody. They're all starting to glow a little bit. This is really glowing. All of a sudden, it gets so fast, it pulls itself out of its own wave. And here, it's just off the charts explosion. The white, whenever there's a push and a shove, the more push and the harder to shove, the more and more glow. Glow is energy. Illumination is energy. Just look it up. It's energy. And then when they come out of the venturi on this side, they turn back into Higgs fields, almost like they were when they started. Except here they're spinning. They have all those little dots. And they do, it's just, that's standard. So they're spinning when they come out of here. When they come in, I don't know if they're spinning or not. That doesn't look spinning to me. This just looks like a wave. Like a particle is just moving. Now, at some point it starts to spin like hell. And I don't know why. But these are the particles. The green, blue, red, I don't care what color, they're all the same. Now, well, let me just show you a better shot. But you see what we had here. The wave starts like this, and it's a wave because there's a particle inside that has a field around it, just like I showed you with the magnets. And it's pushing through everybody else. So this magnetic field, let's just call it a field, has to push through everything else. Then it explodes. Let's take another look and see if we can see anything else that looks interesting. So we've seen the particle accelerate. We've seen it actually pull itself out of its own wave. We've seen it gain energy to the point right here, which is the area that the atomic explosion, subatomic explosion, comes back at. If you look back here, you're going to see a reverse magnetic field there. You see that? You see how tight that is? That's an atomic explosion, subatomic. It's smaller than atoms. This is fission. Black's broken away from the white. And that is fusion, where the black comes back to the white. There is no other way to explain that. It's zero. We saw what that particle started like. It was black and white together. You break them apart, that's fission. You put them back together, that's fusion. You explain to me if that's not what I'm saying it is. I'm saying fission, breaking apart, fusion, putting back together. Now, we know the particles are all the same. Because here's the red ones in black and white. And now this is what's called an upspin, because the particle up is the energetic one. This is the particle down. That's a downspin. Simple as that. And those are photons. These are photons too, from a green laser. They're much more energetic, and that I can prove. And they're always straight up and down towards the Earth. Even though it's going on this direction, it's not spinning this way. It's still spinning this way as it goes. And it's got to do with upspin and downspin, which is the gravitational field is interacting with these particles, all light particles. We saw the acceleration, the explosion. We've seen all these little bits and pieces. Now let's see, this is when blue slows down. We can see blue coming out of the laser and then slowing down. As those fields open up, it means it's going slower and slower. The tighter the field, the slammer it gets. And that's where you have your energy and your mass. All right, so it's got, my thing is energy is mass, which is the photon is a photon, a photon, a photon, a photon. It weighs exactly the same thing. I don't care what color it is. And then how much is being pushed. And in this case, push can go into spinning around in circles, which it is. And you can see it comes in real fast and slow down. And we can see that the two particles are there. Photons are photons. And that's the same particle, just much, much faster. And blue, at a certain point, will damage you. All right, the green and the red, not so much. And here's the green and red together. You see how weak the red is? And how strong the green is? And it concusses way out here. That's the difference. It's just the push of that particle, how much it impacts with something. It's not a real confusing thing when you start to look at it. Now here's a good shot showing you how the interaction right at the beginning when they're starting to be put back together and how they sort of splay out and open up as they come way out to here. And they're just losing energy. And we're going to lose energy as we come through this universe. So the Webb telescope saying, oh, we just found something a zillion miles away because light never slows down. Of course it slows down. Obviously it slows down. I can't imagine them making that argument. I just can't imagine it. And like I say, even 12 years ago, or whatever it was, 2013, Tom Lincoln said empty space isn't empty. It's just like a bubbling head of all little particles twinkling in and out, because they're particles. Stuff doesn't leave the sun and become nothing, and then all of a sudden here on Earth it becomes heat and drives a solar panel, obviously. So dipole electron flood theory is basically the only viable theory that's working right now. If somebody can talk to me about it and we can discuss it and they can come up with claims against my claims, I'd love to hear that. I would love to hear that. So that's what I'm asking for. Anybody, please, let's have an open discussion about this. I will present my evidence, you can present your evidence, or dispute my evidence, whatever you want. But I think that's what needs to be done. Otherwise, until we start understanding the nature of the atom, we're just walking around in circles and spending billions and trillions of dollars. But now they've come down to my size, which is dipole electrons. This is being done now at CERN and Fermilab and all of them, I believe. If it isn't, tell me, no, we don't do that stuff. We don't do. Well, I'd like to first of all know if anybody would say that, because I know that's not true. And secondly, if it is true and I'm wrong, which in my opinion I could be wrong, but if they're not doing that, why? All you want to do is to create the white energy away from the black particles. And I showed you in the house being knocked down, we can do that. The white got to go away and the black has to be kept back. Instead, everything went together. But if we could go to that venturi and then just the white squirts down in here into our collector and the black gets pushed back, which it does, and they're doing, like I say, I'm watching their experiments and it's doing the same thing we're doing, as far as I can determine. All right, this is hard to believe, but it's true. These are muon neutrinos. That's what they claim. They never change size when they hit the heavy water. Cherenkov radiation, however, though, with the attached electron neutrino, goes into a shower. Precisely what I'm showing here. We don't have to hit heavy water. We need to funnel them through a venturi, is exactly what we did. All right, it just doesn't get any simpler than this. A bright light has more energy in it than a dim light. This conclusion matches the observation from the first tutorial. As we increase the electrical energy, more electricity supplied to the lamps, more electricity, they became brighter. Yes. So if it's dim, you have less electricity. If you make more electricity, you make the thing glow brighter, and that's exactly what we did. We created electricity. If you can't see that that's brighter than this, you got an issue. This is an increase, and they know this. I'm watching what they're doing at CERN and all the rest of them. They're doing the exact same thing, but very, very slowly. And all of the muons bounce back from here. So your muons come real hard into here, and then they bounce back, and we squirted the electron showers through here. Now, if we could harvest that right here somewhere, because we can focus this. It's not just a random splash, although right now it more or less is, but we could focus that better, but still, that's not too damn bad. This is raw electricity. This is what you put in your car, your everything that has a battery. That's what you put in, is that white stuff. It doesn't increase the weight, but it increases the energy. The black stuff bounces back. Now this is how I know they're doing exactly the same thing we're doing. These are the muons, and they come up and they bang and they just sort of stop. Here's the electron showers. They come in and they come in low, and then they shower and they create high energy showers. High energy, luminous, brightness, high energy. These are where there's energy. The muons just back off. Now what's the energy? How much energy is there really? Let's see. All right, now I showed you that we did this. We did this, there is no question whatsoever. This is the max energy. This is how much energy there is. When it comes in, not much energy. Just before it hits the venturi, you get a little bit of energy, and then right up through the roof. Why so much energy? Because of the showers of electrons. This is the number, actual number, base tracks of the showers of the electrons. So they're coming in, and they, you squirted a bunch of them in, and they're building and building, and they build and build, and then they sort of dip to nothing, and thousands of times. This is 3,000 times more than what it started with, or a couple thousand times, even 1,000 times more. That's not bad. Now, this is not from me. I didn't make this stuff up. I think this is from CERN or Fermilab. One or the other. They agree with this. Nobody's disagreeing with me. I haven't had one disagreement yet. I'm waiting for somebody to just talk to me about it. If they have a disagreement, I'd like to hear it. One other thing you should probably notice is that you see all these different colors? White light is all colors. So they may not be the same spin rate on every one of these particles, but combined together, all those colors make white. Okay, so this was my proposal originally, was to use the venturi and collect through some kind of a solar harvester here. And there's a bunch of new things that they have, transition metals and so forth, thin films that they can collect all of the energies. See all these different energies? These are different colors. It means they're different energies. Well, you got to collect all of them. You can't just collect one thing, and you got to collect them all. And that requires transitioning of electrons, and then giving off that electron energy through a photodiode, basically, which would be the light energy goes through and it can't come back. There's a gate. And then you do anything you want with it. You put it in a little handheld thing like this and carry it around. But this is the key. You got all these different colors. So what you need is something here that can, like transition metal collector. Have all these different transition metals in it, and they can jump. You want to collect as much energy out of this blast that's coming through here as you can. And that's going to require a lot of thin films. And like, is it a little bit of engineering? Not much. All right, so let's end where we started. This is fission, and that is fusion. There's no question whatsoever, zero question. Before they hit this, they were comprised of two particles together. This was what was coming down here. When it hit, the black broke from the white. That is fission. There's no other possibility that you can think of. That is fission, and that is back to fusion when they came back together and turned back into these type of particles. In the midst, they were completely separated particles. That's fission, fusion. So, as far as I'm concerned, this is the first time anybody has shown and proven nuclear, subatomic fission and fusion. I mean, you can break things and they'll come back together. That's fission and fusion, yes. They take bombs, they blow them up, they come back together, the particles eventually come back together. That's fission and fusion, yes, I have no problem with that. But this is subatomic, visually seen fission and fusion. So I'm going with that. All right, I love you all. Thank you. Bye. Okay, get ready, my friends. I am claiming that this, for the first time, anyone has